Next, we're getting into our stats unit, so we're going to start by taking a look at some measures of center and some measures of spread. So the measures of center that we're looking at, you should be familiar with. We're looking at mean, median, and mode. Measure of center is a value that kind of describes the center of the data set. So mean, as you know, add them all up and divide by the total number. It's our average. Median is the number in the middle. Especially when there's an outlier, a number that's a lot bigger or a lot smaller than the other data values, the median tends to be a better measure of center than the mean. And finally, the mode, which really isn't necessarily a measure of center. It's simply the number that occurs most often, which can be close to the mean or the median, or it can be pretty unique. All right, so we're going to start by taking a look at calculating those values just real quickly. I'm sure this is review for you guys. All right, starting with the mean, we're going to add up all of our values. One thing that might not be review, you may or may not have seen this notation for the mean before. This is called X bar. It just notates the mean. It's a different way to represent or to say the mean. So we're going to add up all of our values. When I add them all up, I got 59. And then we're going to divide by the total number of data values. We have 7 data values. 59 divided by 7 is about 8.429. So next we're going to get our median. Median is the middle value when the numbers are in order smallest to greatest. So we can't just grab this list the way that it is. We have to organize it. So obviously 6 is our smallest value. We have 2 values of 8. We have 3 values of 9. And a value of 10. So when you have an odd number of data values, your median is right in the middle, which is what we have in this case. 3 values smaller, 3 values larger. When you have an even number of data values, you average the 2 in the middle. And finally, our mode, the number that occurs most often, is 9. So in this case, because the mode and the median are the same, I would say 9 is the better measure of center than the mean. Moving on to our measures of spread. A measure of spread describes how similar or different the data set is to one another. So for example, if we looked at the heights in a class of kindergarten students, they would probably all be within a few inches of one another. Whereas by the time they get to high school, they tend to be more dissimilar. We have people really tall or people not so tall. So the measure of spread, or the variability in the data, would be much smaller for that kindergarten class than it would be for a class of high school students. So we've got range. You take the maximum value minus the minimum value. The quartiles. What a quartile does is it divides the data set into 4 equal groups. So you find the median. That's actually called the second quartile. The first quartile is the median of the lower half of the data, and the third quartile is the median of the upper half of the data, and we'll see how to do that. And you end up with the same number of data values in each group. And the 5-number summary is when you look at the 3 quartiles, the first, second, and third quartile, or the first quartile, median, third quartile, and the minimum and maximum values. Interquartile range describes the variability in the middle 50% of the data. So the range overall, the maximum minus the minimum, would include outliers, so it could be misleading if you've got a data value that's a lot bigger or a lot smaller than the rest of the data. Whereas that IQR, the interquartile range, you take the third quartile minus the first quartile, and that gives you the spread or the variability in the middle 50% of the data, and that is sometimes a better predictor of how variable the actual data set is. And we've talked about outliers. There's a formula for finding outliers, and I'll show you how it works, but it starts with multiplying the interquartile range by 1.5. All right, so we're going to find the 5-number summary, starting by finding those quartiles, and I arranged our data in order to save us a little bit of time. There are 18 data values. Since that's an even number, to find the median, we're going to find the average of the 9th and 10th data values. So that gives us right here, 7 and 8 are the 2 data values in the middle. So the median would be 7.5. When you're finding the first quartile and the third quartile, you do not include the median. So if the median is one of the data values, you do not count that when you split the data set in half. So now we're looking at just the data less than 7.5, and we're going to find the median again. So now we have 9 data values, so we have one that's right in the middle, so that's our first quartile. It's also known as the lower quartile. Then we're going to do the same thing for our third quartile, or our upper quartile. Find the one that's right in the middle. So our third quartile is 9. So for the 5-number summary, we take the minimum value, first quartile, median, third quartile, and maximum value. So that's our 5-number summary. And if you notice the way that I kind of divided that data set, so we have in the lower part or below the first quartile, we have 4 data values. Between the first quartile and the median, we have 4 data values. Between the median and the third quartile, we have 4 data values. And between the third quartile and up, we have 4 data values. So when I said it splits the data into 4 equal sets, that's what I was talking about. There's an equal number of data values in each set if you don't include the quartiles. Next, we're going to find the range. So that's the maximum minus the minimum. 20 minus 2 gives us a range of 18. The interquartile range is the third quartile minus the first quartile. So we've got 9 minus 4, which gives us an interquartile range of 5. What you want to think about for the variability or the spread of the data is that the range should be about twice as big as the IQR, because the IQR is the range of the middle half of the data and the range is the whole data set. So the range includes twice as many data values, so it should be about twice as big. And what that would say is that the spread of the data is consistent through the whole data set. Because our range is between 3 and 4 times as big as the IQR, the bottom half of the data and the top half of the data are much more variable or spread out than the middle half. And when we actually look at the data set, it's the top half of the data that is much more diverse or dispersed or spread out than the rest of the data set, or different. That's another way to look at it. So to determine if we have any outliers, we're going to use the formula 1.5 times the IQR. So that's how we start. Once we have that value, what we do with it is we take the lower quartile, or the first quartile, and subtract that value from it. So 4 minus 7.5 gives us negative 3.5. If we had any low outliers, they would be less than negative 3.5, not equal to, simply less than. Of course, we don't have any negative data values, so we have no low outliers. To find out if we have any high outliers, we take the third quartile and we add the 1.5 times IQR to it. This gives us 16.5. We do have one data value that is bigger than 16.5, so that is our outlier. This also affected, as we saw, the range. The range was much bigger than the IQR. That outlier is the reason for it.